Good afternoon. So this is just a video update, video version of the Climate Driver update. So I will discuss here, possibly in a bit more detail than I did go in the text version. So we'll see how we go as I go along. So this is just a video version of the Climate Driver update that I posted recently. Now, before I begin, I will just bring up a few things that I feel need to be brought up. First up, there's a lot of confusion out there in regards to what climate drivers are. Now, climate drivers are not climate change, so I just want to make that clear. They are a separate, basically what climate drivers are the temporary drivers of weather. So they can increase or decrease rainfall, sunshine, storms, cyclones, tropical lows, other lows, cold fronts, for example, those types of things. So they will affect how they affect us, as in Australia. These climate drivers, they work on a time scale of days, weeks or months, just depending on which climate driver we're talking about. So when it comes to the El Nino Southern Oscillation, that's months. So generally the phases of that particular climate driver, so La Nina and El Nino, they will last months, or even neutral. We can add that in there. They will last months. Now, if you look at something like the MGO, Equatorial Rossby Wave, even, I guess, the Southern Annular Mode, SAM, they act on a period of weeks. Sometimes SAM can be days, but generally it's weeks for those particular climate drivers. And same with IOD, that's on the scale of months typically as well. So that's the difference. So yeah, even though it's got climate in the name, people seem to jump to conclusions. It's not climate change. It is literally the driver of our climate as a whole. So driver of everyday weather, or weather over a period of days, weeks or months. So that's basically that. Okay, there is something else I will go into later, but that I'll get into that a bit later on, so when it's actually at the relevant stage. Now, so first of all, we'll go into ENSO, or ENSO. I always pronounce it ENSO, just the way I do it. So that is the El Nino Southern Oscillation. So this is the scale for how we identify La Nina, neutral, and El Nino events in the central tropical Pacific Ocean. So looking at the current observations, it's close to what I call true neutral, which is near zero. Below neutral is cool neutral, and above neutral is warm neutral. But at this current period, we're at minus 0.06 degrees Celsius from average, so it's pretty much close to dead on zero. Now, just to clear up a little bit more confusion about things, Sky News incorrectly declared La Nina about a month or so ago. They're not even the authority to do that, so I'm not sure why they did it, and they only did it after the threshold had dropped below minus 0.8 for like a day or two, or a week, or whatever the hell it was. That isn't the criteria that Australia uses, which I will go into next, because the other confusion is the US declared La Nina. So I see people asking, well, why hasn't Australia? Simply put, it's different thresholds. Australia has different criteria because La Nina, or ENSO as a whole, affects us at different levels. So for our criteria, we need to have, for the SSTs, so the sea surface temperatures, we need it to sit, and this is just for La Nina, I'm going to explain here. So we need it to remain at minus 0.8 for at least 3 months. So that's one of the criteria. Whereas in the US, they only need it at minus 0.5, and I don't think it needs to hold for very long before they declare it. And that is simply because the driver affects both countries completely different. So in that instance, so that is why there is separate thresholds. Now, what I will note is we did have some La Nina-like conditions from time to time, where the atmosphere or the sea surface temperatures have acted as if it was La Nina, but it officially wasn't. So there is that. That does happen quite often. But for the end of 2024, the second half of 2024 and so far into 2025, the ENSO thresholds in Australia have been neutral. Now, moving on, here we have the El Nino Southern Oscillation ENSO outlook. Now, what I will note before I get into this is outlooks from around sometime in March to about the beginning of June are generally considered low accuracy. Don't know why, but modelling struggles during the autumn period with the ENSO. So, with that being said, these outlooks right here are to be taken with a grain of salt, but you can use these in conjunction with, if conjunction is even the right word, but you can use them with the observations to kind of look at trends and what's happening. So, in the outlook currently, we have a trend going warm neutral. So, and even some of the assemble models of the BOMS forecasting also have El Nino, or even a couple have gone down back into cool neutral. So that's something to watch and see how that turns out, because we know what happened with the long-term modelling last year. What was meant to happen did not happen, so there's that. So we can just keep an eye on this and just see what happens. Next, we have the Southern Oscillation Index, or the SOI. This is a measure of the pressure difference between Darwin and Tahiti. I think I pronounced that Tahiti correct. So that basically tells us the pressure difference. Now, in the pluses, +7 or above is generally indicating a La Nina state, or, as I've mentioned earlier, when the La Nina-like conditions took over. So you can see in the previous readings that there were a few times that it was over that +7, which is when it coincided with the wet periods that we did see in places. Currently, the pressure over Darwin, which is where I'm sitting at the moment, and it's a blue sky mostly, starting to clear up, so that bodes well for storms later, but that's completely off topic. The pressure difference between the two locations is Darwin's higher pressure than it should be, and higher than Tahiti currently. So this goes hand in hand with ENSO, because both of them are used to measure if a event is underway or not, and because they haven't actually remained consistent in their relevant phases for La Nina, that's why it wasn't declared by the BOM. I could be wrong, but the National Weather Service in America, I don't think they couple the SSTs and atmospheric conditions together to make their declaration, whereas the Bureau does. So as I mentioned earlier, the criteria here are a lot stricter than over there. So let's move on to the next driver. Okay, so next we have the IOD, which is the Indian Ocean Dipole. This is basically the Indian Ocean version of ENSO. Currently it's neutral, which is always the case at this time of year. IOD will always be neutral during most of the Australian summer. Sometimes it will remain at its positive phase into January. I don't think it's ever done that with its negative phase. I could be wrong with that, but I don't remember it ever staying that long. Because generally in a negative phase, sorry, I had to pause the cough. Generally in a negative phase, the monsoon is early. So when the monsoon's in the southern hemisphere, that is when IOD gets pushed to neutral. So generally speaking, you won't get generally won't see a negative IOD going into January, because of the monsoon normally comes early, which means that the IOD event breaks down. And that is why you will usually see a positive event go into January, or you can see a positive event go into January, because the monsoon is usually late during those events, which means the IOD can hang around longer. So during the summer, most of the summer and into the autumn, because the monsoon is active somewhere in the southern hemisphere, it stops the IOD from forming a negative or positive event. So at this time of year, it's generally irrelevant, but I just like to touch on it anyway, just to bring attention to what it's doing. Okay, moving on here, we're bringing up the IOD outlook. Once again, like the ENSO outlook, these outlooks at this time of year are generally less accurate. But again, like before, bringing it up just so we can have a look at it, and then we can compare it as we go along with observations. So at the moment it's trending towards a cool, neutral, or negative phase, which is really unusual considering the Pacific is going to a trending towards a warmer phase. You don't usually see these two in opposite phases, but it's not unheard of. Now, as you can see with the assemble models, so all the different separate models, there is a bit of variation, and that's why this time of year is terrible. But I just bring it up so we can keep an eye on it. So there's that. So let's move on to the next one. Okay, so we have the Southern Angular Mode, or SAM, as it's called for short. Now, the Southern Angular Mode is basically indicates the position of the cold fronts and belt of westerlies below Australia for the relevant season. So in a positive phase, they are further away from Australia. In a negative phase, they are closer to Australia. I think that's the way it goes. From memory, I'm having a bit of a brain fart, but I'm pretty sure that's how it works. Anyway, basically, let's just tell you how it affects us at this time of year. It's currently in a positive phase, and what that generally means at this time of year is there can be an increase in rainfall across Southeast Australia, because the low pressure systems are generally further away. So it is that way. And the trade winds can bring in some moisture off the Coral Sea. That's generally what happens. Unfortunately, it hasn't been quite the case. We did have a good, strong, wet phase a while back, but the wet was actually affecting the other side of the world, whereas places like Victoria, southern New South Wales and South Australia remained dry. So that was really quite annoying. But anyway, so a positive event in summer or early autumn will cause can cause weather conditions in Southeast Australia. However, a positive event in winter has the opposite effect, and it usually causes drier conditions over Southeast Australia. So yeah, it's currently positive, so hopefully it does bring a bit of something for those southeast states. Now, what is worth noting here is as we approach getting further into autumn, SAM doesn't really do much for Australia. Basically, because of the position of the cold fronts during autumn, positive, negative, it doesn't really push them into any particular wet or dry phase. So during autumn, unlike spring, which is more of a weak summer effect, autumn has very little influence on the Australian climate when it comes to SAM. Now let's have a look at the outlook for SAM. So here's the outlook for SAM. It's expected to remain within the positive area for about a week or so. But what's worth noting is SAM is very unpredictable. It could actually go negative, within a day. And no one would know. Because SAM can be very, very unpredictable and change at the drop of a hat. So when I was on about weekdays earlier, SAM can actually change within hours. So it doesn't always do that. It's normally quite slow, but it is possible and not unheard of it to change within just a few hours. Now the next few weeks, SAM's usually not very reliable past about 2 weeks in the future because of what I've just mentioned, but it's expected to remain positive for a little while there before returning to a more warm, neutral, I guess you can call it. It's not really based on temperatures. Well, it's not based on temperatures at all, so warm's really not the correct. I guess positive neutral would be more accurate with this particular driver. But as you can see, the actual model runs, the outlooks and ensembles for them all are everywhere, and that's completely normal for the southern annular mode. Now moving back to the tropical weather, we have the MGO. Now the MGO is a west to east moving cloud band that moves close to the equator. And this usually has a turnaround of around 30 to 60 days, so it comes back around every 30 to 60 days depending on the speed of it. And it will generally, in the summer months for the southern hemisphere and early autumn as well, will increase weather over the north of Australia as it brings in excessive cloud cover. Currently the MGO is located in the western Indian Ocean, so it's kind of close to Africa at the moment. It's a moderate to weak strength at the moment. Now as it moves east and ends up in our neck of the woods, it's expected to weaken. It may hold its strength, it may not, but the mean of the ensemble shows a weakening. Now, that being said, it's still expected to cause an increase in weather. There's a chance that it will initiate most likely the last monsoon burst of the season, and it could set off some lows as well. So there's that to watch. Now, this brings me to something that has really, I hate to say it, but irritated me, something chronic. But there is certain other people out there that mislabel things. And I just wanted to clear this up. Not every MGO is a monsoon. And not every monsoon needs an MGO. Not every low or weather event in the north is associated with a monsoon trough. And this is what has been said on some posts that I've noticed pop up, that they're labelling every single event, rain event, low pressure, as a monsoon. It's not correct. It's mislabeled. Officially, we've only had one monsoon burst all wet season on the Australian monsoon, on the Australian mainland. That is what caused the floods in northeast Queensland, and also we got the onset up here in Darwin around the middle of February. So between the end of January and the middle of February is when the monsoon was active on the Australian mainland. All other times there has not been a monsoon active across the Australian mainland. We've seen a monsoon trough out in the Indian Ocean. We've seen a monsoon trough just to the north of Cape York back in, I think it was December or January, which caused some monsoon-like conditions. But true monsoons, we've only had one. Cyclone Alfred was not attached to a monsoon, and the rainfall expected in northeast Queensland is not going to be caused, or at least initially. I mean, it could end up being enhanced later on if a monsoon does form, but in the next few days the rainfall that is coming for North Queensland is not caused by a monsoon either. And I will go into what actually is causing that shortly. So I just wanted to address that because I like to make sure that the general public has the correct information, so that when they go around and read these different posts, they can make a little bit better of a guess if they listen to it or not. And, you know, at the end of the day, people can just think I'm talking crap as well. You know, that's entirely up to you. You know, we're all free to think what we like. But, yeah, I live with the monsoon up here. So I know it like the back of my hand even, not head. Because basically it is part of life up here, of watching the monsoon and what it is. And I will make a post on my page and probably accompany it with a video explaining exactly what the monsoon is. So what you need to look out for on modelling for monsoons, so that kind of thing. So just a bit of an educational post and video, so that you do know that if someone goes, oh, there's a monsoon, and you're like, well, no, there's not, because this isn't there. And I'll do that, so that's no worries. Anyway, moving on. After my little mini rant there, so I apologise for that, but I just wanted to clear up that. Now, moving on, as I say, the northeast Queensland rain. As I mentioned in a post the other day, it's nothing overly special for March, because March generally is the wettest month on the northeast Queensland area, especially the wet tropics. So seeing about 300 mil in a week isn't anything overly exciting. The only concern that I would have is if bigger falls like 100 to 200 metres were to fall around Townsville. That could cause problems because the ground is still saturated. So there is that. But elsewhere shouldn't cause too much of an issue. And as long as it doesn't all come in a few hours, even northeast, even Townsville shouldn't get any issues either. But what is causing it? It is something that's very not publicised very often, and I don't usually include it in one of these climate updates, but I did this time. It's called an equatorial Rossby wave. So you get these down in the temperate regions, but this one is one that travels around near the equator. And this one is a east to west moving feature, and it is that in coupling with a weak low pressure in the Gulf currently forming, which is going to cause that rain. which is actually going to cause an increase in rain across the north. In Darwin up here, we're already seeing a bit of that effect. We've been having quite widespread rain and storm lines coming through across from the Gulf. So we should continue seeing that for the next few days as that approaches. So that's basically what is the cause of the upcoming rain. So I'm having to keep pausing the video, so if I sound like I'm talking a bit strange or getting cut off, it's because I am, because the dog keeps barking at the water coming out the drain, I think. So yeah, I'll keep having to pause. Anyhow, so yeah, that's what's going to be causing that that rainfall over the northeast Queensland. So it's not a cyclone, it's not the monsoon. It is a mixture of a weak tropical low in the Gulf and the equatorial Rossby wave coming across as well. So that brings weather with it usually, and it doesn't have a big effect as the MGO usually, but it is going to increase cloud cover and rainfall over the north of the country. Once that's passed, we're going to have the MGO coming in, which will then continue that increase in weather. So it's going to be an interesting end of March. So we will continue watching that and post updates when needed. Thank you very much for watching, and sorry it was so long.